I'm going to solve, thank you. I'm going to solve problem number 4 from the mock test. A student shoots a rocket up in the air from the ground. The rocket's greatest height is 56 meters. Okay, so let's draw a picture of this. Okay. It goes up, it goes down, and this is 56 meters. Okay. And I think we can do A and B and D. Actually, we do A and B together. Okay, so for A and B, which is with what velocity did the rocket leave the ground and what time did the rocket take to reach the top, I think we can solve that. I think this is what we know. I think we know the acceleration was negative 9.8 all the way up. I think the displacement was positive 56. And then we know that the velocity at the top is 0. Because, how do we know that?
If it's not at the top.
If it's not 0, it's not at the top, is it?
Right, so I think the thing to do here is use this guy. I think we can use this to find our initial velocity. So 0 squared equals VI squared okay. So basically VI is going to be the square root of this and just make that positive. And so I get 33.13 meters per second. And that's positive. I could choose either a positive or a negative answer, but I'm going to choose the positive because I know that when it started going up, it's going to be going positive up, right? It's going to be going upwards, which is positive. And then it says, with what velocity did the rocket strike the ground? Well, if this is positive 33.1, as you learned from your quiz, right, the other day, it's going to hit the ground with negative 33.1 because it's the same elevation, okay? So we've answered number A, problem A with that, right? Okay, and then it says, what time did the rocket take to reach the top? I think to find time, I would use this guy. VF is VI plus AT, so the final is 0. The initial is 33.13 plus negative 9.8 times time, and then we can solve for time, right? So I'm going to divide that by 9.8 basically, right? It's just going to be this divided by 9.8. So I'm getting 3.3806, right? So there's the answer to part B. Here's the answer to part A. And now I think we need to do a little more figuring, right? So C says, what two possible velocities did it have at 50 meters above the ground? That's going to be here. And I expect there to be a positive answer for the upward trip and a negative answer for the downward trip at 50 meters. Right, so this is for C. Okay, for C, we know this. I believe we know that the displacement's 50 meters, right? We know the initial velocity is the same, right? We don't know the final 0 because we're not at the top, right? But we do know we're on Earth, right? And now we know 3 things, okay? And then it says what two possible velocities. I would use V final squared is V initial squared plus 2AX, right? So 33 plus 2 times negative 9.8 times 50. Okay. Okay, and then when I square root this, I get that the final velocity, the absolute value of it, is 10.84. So it's either positive 10.84 or negative 10.84, right? It's positive on the way up, and it's negative 10.84 on the way down, right? That's why there's two answers. And then it says, D says, what's the rocket's velocity and position 5 seconds after it's launched? That's yet another thing, right? Okay, so this is D. Okay, we know the time is 5 seconds. This is negative 9.8 meters per second. The initial velocity, we'll use the same one, right? It's the same launch. Okay, and then that's what we know. And that's 5 seconds. That's meters per second, right? Okay, and then to find the position, I would use x is VIT plus 1/2 AT squared. In other words, I'm going to use the one with no V final for that one, right? And then for V final, I'm going to use the one with no x, which is V final is VI plus AT, right? Let's do this one first. Okay, so 33.13 times 5 plus 1/2 negative 9.8 times 5 squared. And don't forget to square the 5, right? Okay. Plus 0.5 times negative 9.8 times 5 squared. We're getting 43.15 when I plug in those numbers. Is that right? There we go. Okay, and then to find the final velocity, I'm going to use VF is VI plus AT. Right, so it's going to be 33.13 plus negative 9.8 times 5, right? So it's going to be on the way down. This is going to be a negative number. So alpha V is where I stored that, plus negative 9.8 times 5. And I'm getting negative 15.86, so negative 15.9 meters per second. Is that right? Yeah. Okay, so we've caught it at 5 seconds. At the top, it's at 3.38, so at 5 seconds, it's here. It's moving down at 15.9 meters per second. It's 43 meters above the ground. And yeah, what do you say at the end? And
Done.
it's very important that you, no, that's annoying, isn't it?
Cut.